Hello and welcome to this brand new section on desktop application development with PyQt. So in the previous section, we have already learned how to make desktop apps with Python using Kinter, but this section is solely going to be focused on PyQt. So now you might obviously have a question in your mind, and that question would be why exactly you should learn desktop application development when the world is actually moving towards web development. So almost all the jobs which you see in the market, it seems like there's a huge demand for web developers. So why exactly should you learn how to build desktop apps? So the first reason for that would be supply and demand. Now, as there's a huge demand for web developers, what usually happens is a lot of people start learning web development, and this often leads to less supply of skilled developers in other domains such as desktop application development. So for example, if you go in the job market today, most of the candidates would have all the skills essential for building websites. But if you talk about building desktop applications, then a very few people have the skills to build desktop apps. And that's what makes it so valuable. Even though desktop application development is not trending, but still there exists a demand for that specific domain. And often, as there are very few developers who could do that, that means this is also a great opportunity. So that was the first reason why you should learn desktop application development. The next reason is that it teaches you the fundamentals of software development. And the principles of software development are similar across all the domains. So for example, if you take website development, application development, mobile development, or desktop app development, all of these domains are different, but the core philosophy or the core functionality of how things work in all of these domains are exactly the same. So we use the same software design principles, we almost use the same practices, so on and so forth. So learning how to build desktop apps is also going to give you an edge in understanding how to build web applications or mobile applications as well. So that's another reason why you should not shy away from learning how to build desktop applications. So this was just a brief overview to kind of give you an idea of why exactly we are diving deeper into desktop application development. So in the next lecture, let's go ahead and let's have a brief introduction to PyQt. Let's understand how powerful PyQt is for building desktop apps. So let's learn about PyQt in the next one. Now let's learn what exactly is PyQt. So what is PyQt? So PyQt is actually comprised of two words. First is Py, which stands for Python, and if you talk about Qt, Qt is a free and open source cross-platform C++ framework for creating GUIs as well as cross-platform applications. So what exactly do we mean by that? So in PyQt, Python is one thing and Qt is a completely independent framework, and it's actually a C++ framework. So Qt has got nothing to do with Python. Qt on itself is a framework which is developed by the Qt company, and that framework is built fully with C++, and you actually need to write C++ to access that Qt framework. Now this Qt, which is a framework, is used for creating graphical user interfaces, and also it's used for creating cross-platform applications as well. So by cross-platform applications, we mean the applications which could run on multiple devices. So they could run on Mac, Windows, Linux, Ubuntu, as well as these applications could run on embedded systems as well. So what exactly are embedded systems? An embedded system might be something like your fridge. So if you want to design a user interface for a smart fridge, you could use Qt for that. And another example where Qt is extensively used is to design the digital cockpits or digital speedometers of modern cars. So if you take a look at the speedometers of modern cars, they are fully digital, and most of those are actually built with PyQt. So that's an example of embedded systems. And also Qt is available under both commercial and open source licenses. That means if you want to learn PyQt, it's absolutely free. But if you want to develop some commercial application with that, then there is a fee which you need to pay to the Qt Foundation. PyQt also provides us with features such as networking and file handling. So the Qt framework is not just any other framework which just allows you to create some buttons and widgets, but they also provide you with some additional features such as networking. That means you could connect to the internet, you could connect to multiple devices as well. And it also provides you features like file handling as well, using which you could access the files stored inside the memory. So this is what Qt is. Now let's try to understand what is PyQt. So the Qt framework was originally used to create user interfaces and cross-platform applications. In order to create Qt applications, you had to know C++. So if you are already familiar with C++, then you could directly use the Qt framework. But C++ is kind of a hard language to learn, especially for beginners. And therefore, for this reason, PyQt was introduced. And what PyQt allows us to do is that it allows us to enable writing Qt applications with Python. So in PyQt, technically what we do is we use Python to write a Qt application, and you do not have to deal with C++ at all. And this is possible because PyQt is a set of Python bindings for the Qt framework. That means PyQt actually provides us with a set of classes which we could use, which directly allows us to use the functionalities of the Qt framework, and we do not have to deal with C++ at any point of time. So PyQt allows us to use the Qt framework's functionality with Python. And also, as mentioned before, PyQt provides us with Python classes that corresponds to Qt's C++ classes. So obviously, as Qt is a framework, in order to use that framework, they have provided some classes in Qt, but those are C++ classes. But if you want to use them with Python, you could do that with the help of PyQt. So this is what PyQt is. Remember that PyQt in itself is not a framework. It's simply a set of Python bindings for the Qt framework. So in PyQt, Qt is a framework, Py stands for Python, and PyQt is nothing but it's sort of like a Python, a wrapper for the Qt framework. So this is what PyQt is, and it's very essential to understand this even before we start learning PyQt. So the next question that would be in your mind would be, why exactly you should learn PyQt if we already know Kinter? And that's actually a good question. So let's answer that in the next lecture. In this lecture, let's learn why exactly do we need to learn PyQt if we have already learned Kinter. So this lecture is going to be a brief comparison between PyQt and Kinter and see how they differ from each other and how one should be used over the other in different scenarios. So the first thing about PyQt is that PyQt is actually a comprehensive and mature library. So if you compare PyQt with Kinter, it's a more comprehensive and a more mature library as compared to Kinter, as it offers a wide variety of features for GUI development. It also provides more advanced widgets, more advanced graphic rendering capabilities, and multimedia as opposed to Kinter. Whereas if you talk about Kinter, Kinter is more of a standard GUI library, and it actually comes bundled with Python. And Kinter does not have the advanced features as provided by PyQt. So that's the major difference between these two libraries. So as PyQt offers a bit more features, it's a little bit more difficult to learn. However, if you take a look at Kinter, Kinter is simpler to learn because it has less extensive features and it's more easier to implement those features. Now PyQt actually comes with tools like Qt Designer. So if you want to design the user interface for your application, typically you would have to write every single line of code from scratch for the UI in case of Kinter. But that's not the case with PyQt. PyQt has a tool called as Qt Designer, which is a drag and drop tool which allows you to design the application's user interface as per your own choice. However, in case of Kinter, Kinter does not include any kind of tools to design the user interface. PyQt has extensive documentation, whereas the documentation for Kinter is not so extensive. So if you go to the official documentations for PyQt and Kinter, you will be able to find that as PyQt is a more comprehensive library, its documentation is extensive as well. Whereas as Kinter is kind of a lightweight library, it does not have a extensive documentation. And the last and the final point of comparison is when exactly you should use PyQt and when exactly should you use Kinter. So as a Python developer, if you wish to build some professional applications and if you want to release them to the market and kind of make your application commercial, in that particular case, you should always prefer using PyQt. And on the other hand, if you do not want to build a commercial application and you just want to build something simple with simple features, or let's say if you want to build something commercial but you want to build it to the prototype stage. In that particular case, Kinter is the ideal library which you should go for. So this was the major difference between PyQt and Kinter, and this is why exactly we learn PyQt even though we have learned about Kinter. So the reason why we have covered Kinter before, because Kinter was relatively simpler to understand. It taught us the different concept of how exactly the UI should be designed, how exactly the components should be placed, how the event handling should take place in an application, so on and so forth. Whereas now we want to dive deeper into learning how to build commercial level desktop applications, and for that very reason we are going to be learning PyQt. So in the next lecture, let's go ahead and let's learn how to set up PyQt6 on our machine and start building applications with it. So thank you very much for watching, and I'll see you guys in the next one. Thank you. In this particular lecture, let's go ahead and let's learn how we could set up PyQt6 on our machine. So if you're on Mac, open up the terminal, and if you're on Windows, open up command prompt. And the first thing which you need to do is you need to first check the version of Python which you're using. So PyQt6 typically requires Python 3.7 or higher. So in order to check the Python version on Windows, you type in Python --version, but if you're on Mac, you have to type in Python 3 version. And now as you can see, the version of Python which I'm using is Python 3.10, which means I could now go ahead and install PyQt6 over here without any issues. Now in order to install PyQt6 on Mac, you have to type in pip3. So if you're on Windows, simply type in pip install PyQt6. Make sure that you have P and Q in capitals. And if you're on Mac, simply type in pip3 install PyQt6. So if I go ahead and hit enter, this will actually install PyQt6 for me. As I already have PyQt6 installed, it says that requirement already satisfied. So now once PyQt is installed, from the next lecture onwards, let's go ahead and let's start building our very first UI window with PyQt. And if you have any issues installing PyQt6 on your machine, then feel free to go ahead and post your queries in the Q&A section. So that's it for this lecture, and I'll see you guys in the next one. Thank you. In this particular lecture, let's go ahead and let's start building our very first application with PyQt. So before writing any kind of code here, what I would recommend is that if you're using Visual Studio Code, then please go ahead and download the Python extension in VS Code. So simply go ahead, go to extensions, search for the extension, which is the Python extension, and then simply click on install and enable that extension. So once Python extension has been installed, here what I have done is I've actually created a folder called as Python app, and in that folder I have simply created a file called as demo.py. And let's go ahead and let's start writing our code here. So as we want to create our application with PyQt, that means we first need to go ahead and import some classes from the PyQt package which we have installed. So the PyQt6 which we have installed here is nothing but, in this case, it's a Python package. That means you need to import some classes from that package. So in order to import that, here I would say from PyQt6. Now remember that you cannot type in PyQt6 like that because this won't work, but instead you have to remember that PyQt6 is case sensitive, which means you have to type in P in capitals and Q in capitals as well. So you have to say PyQt6. Alright, and after this, as this is a Python package, within that package we are going to have a Python module. So in this case, as we are trying to create a Python window, that means we need to use the Qt widgets package, which allows us to go ahead and create widgets. So dot Qt widgets. Now remember that just as PyQt6 is case sensitive, this module name is case sensitive as well. And here, as you can see, it says that it's actually a module. So let's select this, and from this particular module, we want to import a class which is the QWidget class. So here I would say import the QWidget. And what this QWidget allows us to do is that it allows us to create a widget or a window. Alright, so now let's go ahead and understand how we could create a simple window using this. So remember that we will be using the object-oriented approach of writing code here, and that's because while designing graphical user interfaces, it's actually better if we use class-based way of writing code rather than using the functional way of writing code. So here I'll create a class, and let's call this class as window. And over here, we will make this class inherit from this class which we have just imported, which is the QWidget class. And the reason why we do this is because this QWidget class actually has certain methods which allow us to create a window for our application. So that means here I would say this class inherits from the QWidget class. Now what happens is all the methods which we have inside the QWidget are now accessible to this class, which is the window class. Alright, so after this, now let's create a constructor in this particular class. Now this is nothing specific to PyQt, it's just a regular Python concept which is creating constructors inside a class. So here I would say def _init _, pass in self as a parameter here. And the very first thing which we wish to do here is that we wish to call the init method of this QWidget class. And the reason why we need to call the init method of this QWidget class is because that's actually going to go ahead and set up the window for us. Now the question is, how would you invoke the init method of a class which you are inheriting from? So remember that as we are inheriting QWidget class into the window class, now this becomes a subclass and this is a superclass. So here we wish to call the init method of the superclass, and whenever you have to call the init method of the superclass, you make use of the super function. So in this particular constructor, we say super dot, and then we say we want to call the init method, so _init. So what this does is that it actually calls the init method of the QWidget class. So remember that this init method is the method of this class, and this init method which we are calling here is the method of the QWidget class. And after this, right inside the init, what we wish to do is, as we want to create a window, we need to set some kind of a title for that particular window. So here, in order to set the window title, I would go ahead and say self, and over here self means the current object itself of this class. And for that object, I need to use a method called as set window title, and that actually allows us to go ahead and set the title for our window. So over here, let's specify some title like my first PyQt window. All right, after this, the title of the window would be set. And after setting up the title, let's say you want to place these particular windows or size this particular window as well. So in order to set the size of this window, we say self dot set geometry, and in this set geometry function we have to pass in a couple of things. So we need to define the starting point from where this window would be drawn. So for example, let's say you want to start drawing this window from the left top corner. So the coordinate points of this left top corner are 0, 0. So over here, let's say I say, all right, I want to start drawing from here. So the x value for that coordinate would be 0. The y coordinate for that would be 0 as well. Then you could go ahead and set the width and the height for your window as well. So let's say I want to set the width of that window to be 400 and the height to be 300. So I'll simply pass that up over here. All right. So once we are done with this, we are done initializing or setting up this class. Now in order to create the actual window out of this class, we have to go ahead and make use of this class right up over here. So let's go ahead and let's create an object out of this. So creating an object is quite simple. You type in the class name here, which is window, and then you save this into some variable like window. So now this creates a window object. Now remember that this is just a window, but this is not actually a PyQt application. So that means now we also have to create a PyQt application as well. And in order to create that application, we also need to access another class here, which is the Q application. So I would say Q application. And once we have this Q application class, using this class, we create an application window as well. So right before the window, we say app equals, that's going to be Q application. And then let's simply say sys.argv. So what we have done here essentially is that we have created an object of the Q application, and here we have created an object of the window. Now the reason why we have not actually created another class over here for Q application and then kind of go ahead and make some changes here is because we don't want to go ahead and alter anything inside the Q application class. Therefore, we have directly created the object of that particular class over here. However, in case of this Q widget, as we want to modify the geometry as well as the title of that window, we have actually created another class and then inherited the Q widget inside that class and then created object of that class itself instead of creating the Q widget object here. So try to understand the difference here. And this sys.argv which we are passing here is for some arguments. So if you want to pass some arguments while running your application, this is why we have added that over here so that our application would be able to accept some arguments. So once the app is ready and once the window is created as well, our job is to go ahead and then display that window. So this only creates the window and it's not going to display that window. And if you want to display that window, you have to say window.show. So you need to invoke the show method on top of it. So now once our application is ready, the next thing which we need to do is we also need to go ahead and ensure that we are able to close this application as and when required. So what this line of code does is that it actually starts an event loop. And then after starting up that event loop, we also need to be able to go ahead and exit out of that event loop as well. So in order to exit out of that event loop, we need to import a Python specific module which actually allows us to quit the Python program. And that particular module is the systems module. So I would say import sys here. And once we have imported that, from that particular module, I have to use a method called as exit. So here I would say sys.exit. And then to this, you need to pass in the app instance, which we have created here, and say .exec. And that's it. This actually creates one of the most simplest examples of a PyQt window. So now let's go ahead, let's run this code and see the kind of output it produces. So I'll open up the terminal here and I would say Python 3, that's going to be demo.py, and as you can see, this is the window which has been now created. So the title of the window is my first PyQt window. It has a size of 300 by 400. So let's say if you want to change the size of this thing, you could change it to something like 400 by let's say 900. And now if you save this, the change won't be reflected over here. And that's because whenever you make some changes to your code, you actually have to close this application, go back here, rerun your code one more time, and only after that you'll actually be able to go ahead and notice the changes here. So as you can see, this is what the window looks like when we go ahead and resize that particular window. So now let's take it back to 300 and we should be good to go. All right, so this is how we could go ahead and create one of the most simplest PyQt interfaces in Python. So I hope all the code which is written here made sense and you were able to understand why we do what we do here. So in the next lecture, let's go ahead and let's learn about the QLabel widget, which allows us to go ahead and place some kind of labels on our window. So let's learn about the QLabel widget in the next one. Hello and welcome to this lecture. And in this lecture, let's learn about the QLabel widget in PyQt. So the QLabel widget allows us to add labels onto the PyQt window which we have. Now this QLabel widget is not just used for adding text to the PyQt windows, but it also allows us to go ahead and add images to that window as well. So the first thing which we need to do in order to add a label is we need to import the QLabel widget from PyQt6.qtWidgets. So let's go at the very top over here and let's also import the QLabel widget as well. All right. So once this label is imported, now the next thing which we need to do is we need to add that label to the window. So the question is, where exactly would you add the code to create that label? So whenever we initialize the window, after we have set up the size of that particular window, we could go ahead and add widgets to that specific window. So in order to add a label, first of all, we actually have to create the label from this QLabel class which we have. So if you hover over this, as you can see, you will be able to see that this is a class. That means we need to create an object of that class in order to create that label. So let's create that object first. So I would say label equals, that's going to be QLabel. And once that label is created, you also need to pass in self to it. So this actually creates us the object. And now in order to go ahead and add some text to this particular label, we'll use a method called as setText. So here I would say label.setText. And to this setText, we'll simply go ahead and pass in some sort of a text here. So let's say this label would say something like hello world. Now once we have added this text, now you might think that when you run this code, you'll be able to see this label on the window, but that's not the case. Whenever you go ahead and run this code, what happens is it will just create the label and it will set its text to this one, but that label would not be added to the window. So in order to add this label to the window, you need to use a method which is called as move. So here we have to say, take the label and move it onto the window. And then on the window itself, you have to specify at which particular coordinate positions do you want to place this particular label. So let's say I want to place the label at 50, 50. I would simply add that here and we should be good to go. So let's see what happens if I run this code. So when I run this, as you can see, this is what the window looks like and this is what the label looks like. And here is where the label is placed at 50, 50, which is this coordinate point right here. Now what happens if I go ahead and change this thing from 50, 50 to 0, 0? In this case, the label would be placed up over here at the top left corner. So I'll close this window, save this code and run this. And this time, if you take a look at this window right here, as you can see, the label is placed at the position 0, 0. So that means if I want to place this label to the center up over here, that means I need to place it somewhere around 200 and 150. So let's try doing that. So 200, which is the center of this one, and let's say 150. Let's close this window, get back here. Let's run this one more time. And this time you get this window, but the problem is it is placed here because the point which is 200 and 150 is this point right here. That means now you need to shift it a little bit to the left. So let's try with, let's say 180, and over here let's also shift it a little bit to the top. So let's do 110. So if we do that, hopefully that would be placed at the center. So if you run this time, as you can see, it is placed right up over here, which is kind of like a center, but it's not exactly the center. But don't worry, you don't have to place the widgets like that, because eventually we will be learning how to use the Qt designer to design the layout of our application. But this is just to show you how a label could be placed onto a specific window. Now this is just one way of placing widgets onto the window, but there are some more advanced and better ways to place widgets on the window as well, which we are going to learn later. But for now, just keep in mind that this is the way which we are placing the labels of widgets on the window right now. All right. So once we have learned how to place labels using the QLabel widget, let's also learn how the QLabel widget could be used to add images to the window as well. So if I want to add an image to the window which I have, first of all, I need to have an image over here inside my folder. So I'll actually provide you this icon in the resources section. And if you actually want to add this icon over here to this window, then what you simply have to do is you first have to open up this file, which is car.png. So make sure that you have that image inside your Python folder, which is in the same folder as this file, so that we will be able to open it. All right. Now, if I want to add an image, first of all, I have to open that image. So I could say with open. So I will use with open here so that whenever this image is open, we could go ahead and access it. So I'll open up the image, which is car.png. And while this image is open, I'll go ahead and create another label for adding up this image here. So here we have the simple label, and now let's name the other label as image label. So image label is going to be the object of QLabel as well. And over here, as usual, we pass in self. All right. So now once we have this image label, you might think that, all right, now how exactly we could add an image to this label? So in order to go ahead and use image in our Qt application, we have to use something which is called as a QPixMap, which is Q pixel mapping. So first of all, you have to import that QPixMap class from the Qt GUI module. So here I would say from PyQt6 dot Qt GUI import the QPixMap package. And once this package is imported, now what we could do is, using that package, we could actually create a pixel mapping. So here I could say pixmap equals QPixMap, and to this QPixMap, you actually have to pass in the image which you have. So the image which we want to pass in here is the car.png image. So here I would say car.png. And once we have passed that image, now we have this pixel mapping. And what we do is we take this particular image label and add this particular pixel map to that image label. So here I would say image label dot set pixel mapping, or set pix map is the method which we are looking for. And we simply have to pass in this pix map over there. So I'll copy this and pass it up over here. Alright, so now once we have this image label ready, then we could finally go ahead and place it onto the window. And we all know that in order to place something on the window, you actually need to go ahead and make use of this move method. So here I would say image label dot move and move it to 180, which is the same x-axis. But let's say we place this image a little bit below, so I would say 130. So now let's go ahead, close this one, save this code, run our app one more time. And I guess it's showing us an error. Alright, so autocorrect actually added one more car here. This should be car.png, which was a minor typo. And if I run this, as you can see, this is how our window looks like. So in this window, we have the regular Q label, which displays some text. And then we also have this image over here as well, which is the icon of the car. So this is how exactly you could go ahead and make use of the Q label to add labels onto your window and also add images to your window as well. So now we are able to go ahead and add any kind of text and image to our window. So making use of the same knowledge. In the next lecture, let's go ahead and let's create a layout to display a car's image as well as all the detailed information of that particular car. So let's create that particular user interface in the next lecture. In this particular lecture, let's go ahead and let's create a UI layout of a card to display all the details of a specific car. So even before you get started with this specific project, first you need to go ahead and download this image from the resources section. So you could choose any image which you want, but this is a transparent image. That means it won't leave any background color when you add it to the layout. Alright, so once you have downloaded this image, make sure that you have that image up over here inside the project folder. Alright, so once you have this particular image, we could go ahead and start working with the code which we had from the previous lecture. So in the previous lecture, we have this code wherein we have added the label and we have added the image as well. So let's get rid of the label and the image. So I'll get rid of this code from here. And then we have a plain simple blank window. So let's go ahead and let's test this out to see if that window is present. Alright, so if you take a look at this, this is the blank window which we have, and we could start working with this window itself. Alright, so let's close this. Let's get back here. And over here, the first thing which we need to do is we first need to set the size of our window. So let's say we want a square shaped window which kind of looks like a card. So I'll set the geometry of this thing to 400 by 400. Alright, so now once we have the basic window set up, let's open up the image which is mycar.png and then add it to the layout. So in order to open this thing up, I'll use with open. So I'll say with open, open up the image which is mycar.png. And after opening this thing up, inside this particular loop, I'll go ahead and create a label which would actually take this image and contain that image inside that particular label. So here I'll create a label. So instead of calling it label, I'll call it as image label. That's going to be Q label. And then over here, we need to pass in self. And then in order to pass the image to this label, you actually have to create a pixel mapping for that particular image first. So I would say the pix map is going to be QPixMap. So QPixMap, make sure that you have imported QPixMap here. And after doing that, to this QPixMap, I'll simply pass in the image, which is mycar.png. And now let's pass in this pixel mapping to the image label. So image label dot set pixel mapping. So set pix map and then pass in the pixel mapping here. And once that is passed, now we simply have to place this label onto the window at a specific coordinate position. So over here to place the image label on the window, I will make use of the move method. So image label dot move. And we then want to specify the X and Y coordinates, like where exactly this image should be placed. So let's first place it at a position like 50, 0. and let's see how that kind of looks like. So if I save this and if I run this, this is what the card looks like, and it kind of looks okay. The image is a little bit to the left, but that's all right. You could adjust it if you want, but for now let's work with this. So let's get back here. You could also close this window, go back here, and the next thing which we need to do is we need to add the details of this specific car on the card. So we need to add the name of the car. We want to add the engine specifications, features, models, pricing, so on and so forth. So in order to keep things simple, first of all, I'll go ahead and create a code snippet for adding the car name. So in order to add the car name, you obviously need to create a label, then set the text for that label, and then set the font for that label as well, and then finally move that label to a specific position. So first let's create the name label here for displaying the car's name. So name label, this is obviously going to be Q label. We need to pass in self, then we need to set the text. So name label dot set text. Let's simply pass in some text like my car. And then I could simply say name label dot move and move it to the desired position which I want. So as I actually want to display this label a little bit to the center, so the center would be 200, 200, but the label itself is going to have some length. So instead of 200 and 200, I'll say 170, 170. And let's take a look at where exactly this label would be placed. So if I run this, if I take a look at the window here, as you can see, this is what the window looks like, but you'll be able to see that the font here is a lot smaller. So now the question is, how exactly are you going to go ahead and change the font of the label which you place on the PyQt window? So in order to change the font of the label, there's a specific thing which you need to do. So if you go ahead and if you say something like, let's say name label dot, there's a method called as set font. But this set font method which you have, it actually accepts a Qt GUI font. So you cannot simply pass in a simple font, but you need to pass in a Q font object here. So now the question is, how exactly would you create that Q font object? So that means you first need to import Q font itself. So you could go ahead and from the Qt GUI module, you could say I want to import the Q font. So as you can see, this Q font is a class, and this class allows us to create an object. So rather than creating an object anywhere outside, I could directly create that object in here itself. So here I could say, all right, I want to create a Q font object, and to this object you could pass in the kind of parameters which you want to specify. So for example, the first parameter which you need to pass in is the variant. So let's say I want the font to be Arial. I'll pass in Arial here. And after this, the next parameter which you could pass in is the size. So let's set the size to 20. If I do that, and now if I save this and if I go back here, run this code, let's take a look at the font this time. So as you can see, the font of this label has now been completely changed and it says my car. Alright, so after having the name of the car here, let's go ahead and let's also create labels to display the specifications of this car over here. So for this, we'll be making use of the same kind of label which we have used here. So we could copy paste this snippet of code and just make a couple of modifications. So let's close this for now. Let's get back here. And over here, after the car name, let's say I want to define the engine specs. And after that, I want to define the features of the car. And after that, the different kinds of models which are available. And let's say finally, I also want to display the pricing as well. All right. So once we have all of these things, now what I could do for the sake of convenience is I could copy this entire snippet of code for creating the name label. And let's simply replace name label with engine label. So here I would say engine underscore label. And I could use the same name over here, 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 and here. And the only changes which I need to make here is that for the set text, I want to set the label to something like, let's say engine capacity. Let's say it's a 4-liter TFSI engine. Let's assume that. Let's reduce the font size a little bit because this is not a heading, but instead we want to display the specification. And also, let's not put it to the center, but instead let's put it a little bit to the left. So let's make the X position to be 20. And over here, you cannot have the same y-axis for this one, or else the name label and the engine label would be placed on each other. So instead of 170, let's increase it by 40 points. So let's say this is 210. All right. So let's give it a try and let's see how this looks like. So I'll go ahead, run this code. And if I open up the card here, this is what the card looks like. And that's exactly what we want as well. So we want all the features for the car present on the left-hand side. All right. So after adding the engine specification, let's add a couple of other properties as well. So after the engine specs, for the features, I'll go ahead, copy the same snippet of code, paste it up over here. And over here, instead of engine label, I would say something like features label. Let's use the same name at all the places. Let's set the features over here. So I would say features are, let's add a couple of sample features, like it has ABS, it has EBD, it has ADAS. And let's also go ahead and change the y coordinates of this label because you don't want to place it on the same line. So let's increase it by 30 as well. So let's make it 240. Let's do the same thing with models as well. So I'll again copy this, paste it up over here, change this thing to models underscore label, copy the label name, make changes over here, change features to models, and let's display the models which are available. So let's say this car is available in a 2.2 liter petrol and a 1.8 liter diesel engine. All right. Let's also change this thing to 270. And finally, let's add the pricing. So for the pricing, I'll again copy this, paste it up over here, change this one to pricing underscore label, copy this, replace these, change the models to pricing, or you could simply go ahead and directly add the price here. So let's add the price as, let's say, $80,000. And over here, let's simply change this thing to 300. All right. So now if I go ahead and if I run this, as you can see, this is what our card looks like. So it has all the features listed up over here along with the image. So it has a nice looking image, a heading, and all the features of the car listed up over here. So this is the simplest piece of GUI which we have created, and this actually teaches us how to add images, how to add labels, and also how to add different kinds of fonts to the label as well, and also how to lay out these specific labels and the images onto this specific window. Now do not worry, you don't have to go ahead and manually do this every time you create a layout. We will be making use of Qt Designer eventually as we progress in the course. However, it's essential that you know how these things work on an internal level so that even if you make your applications or build your applications with the Qt Designer, you still should be able to tweak the code over here to make minor changes. So that's it for this lecture. And in the next lecture, let's go ahead and let's learn how event handling could take place in a Qt application. So till this point, we have created some basic windows which are not interactive, and we cannot perform any actions with this window like clicking of a button, so on and so forth. So let's learn how exactly those kinds of events could be handled in a Qt application in the next one. In this particular lecture, let's go ahead and let's learn about event handling in a PyQt application. So up until this point, we have learned how to simply create user interfaces, but now let's learn how events could be handled in a PyQt application. So we need to understand that GUI applications are event driven. So unlike the console applications wherein you have to type in some kind of a commands to execute some code, GUI applications, or the applications which have a user interface, are event driven. That means you need to click a button or you need to perform some action so that some code at the background would be executed. Now an event could be a user generated event such as a click of a button, etc. Or it could also be generated by internet connection, window manager, etc. or a timer. So when we think about events, an event is not just a action performed by a user, but it could also be some background action which might take place. So for example, let's say if you want to design an application which actually rings an alarm bell when the internet connection goes off. So in that particular case, the internet connection going off itself could be an event which is not an user generated event. Or you might also want to create an alert when the internet connection comes back. So that's also an event. And similarly, there could be other events as well which take place without the user interacting with the application, such as the event which are generated by the window manager, or let's say you have a timer running in the background. So those events also need to be handled in case of an application. Now the thing is, when the user generated or background event happens, we want to perform some actions. So for example, if a user clicks a button, obviously the user kind of expects the application to react in a certain way. So in that particular case, after the event has occurred, we want to perform some kind of an action. And this entire process of actually capturing the event, managing that event, and performing some action once that event has occurred is called as event handling. And event handling hence is an extremely important concept in case of user interface based applications. So now let's learn how exactly events could be handled in a PyQt application. So even before learning about events, we first need to understand how PyQt itself listens to events. So we know that when we call the exec method of the application actually enters the main loop. So if you take a look at any kind of code here, we have this app.exec method. And what this method essentially does is that it actually puts our application in an event loop or the main loop. That means the application keeps on running. Now, as the application keeps on running and when that application is in that loop, our application keeps on listening to events. So this main loop detects various events and sends them to an event object. So whenever an event happens, what our application does is that it takes that particular event and sends it to a event object. Now, when that event reaches that particular event object, there are actually two ways in which we could handle events. The first way is that we could use event handlers, or the next way is by using signals and slots. So let's discuss what exactly are these two methods of handling events. The communication between objects in Qt is handled by signals and slots. So let's dissect this statement. So the communication between two objects basically means, let's say if you have multiple widgets, and let's say when you perform some action on one widget, you want that action to be reflected on the other widget. So this kind of communication which needs to happen in between these two objects in Qt is actually handled by signals and slots. So now let's understand what exactly are signals and slots. So signals are nothing but they are generated when an event occurs. So for example, when we click a button, we could say that a signal is generated. And when the signal is generated, we want to perform some action. And these actions are performed by slots. So slots are nothing but they are the methods which are connected to events and are executed in response to a signal. And slots could be built-in PyQt functions or they could be regular Pythonic functions. So let's visualize what are signals and slots. So let's say you have a button. When you click on that particular button, a signal is generated. And that signal executes some method or a snippet of code, and that snippet of code is nothing but it's a slot. So essentially a slot is a basic Python method which you have. So these slots, they could be built-in PyQt functions or they could be regular Python functions which are totally user generated. So things will start making more sense when we actually go ahead and take an example to understand how this actually works. So I hope this kind of gives you an idea about how event handling works in PyQt, and I absolutely get it if things are not making sense as of now, but it will get better as we go ahead and take a real world example and understand how event handling works in PyQt. So in the next lecture, let's take a simple example by creating a button and let's try to handle the click event associated with a button and see how this entire mechanism of event handling works. So let's go ahead and let's learn that in the next one. In this particular lecture, let's go ahead and let's take an example in order to understand how event handling works in a PyQt application. So first of all, let's get rid of all the extra code which we have from the previous lecture and let's start with the basic setup. So let's delete the code for opening up the image and for adding all the labels, and let's have the bare bones code which creates a window. So once we have this, now if I go ahead and save this and run this, you should be able to get a blank window over here so that you understand that it's working. So after this, let's now go ahead and let's create a button here, and whenever we click on that particular button, an event happens and we want to handle that specific event. So in order to create a button here, just as we have imported the QLabel class here, we also need to import the QPushButton widget. So here I would say import QPushButton, which is a widget. And once we have that particular QPushButton imported, it's actually a class, and then we need to create an object out of that particular class. So over here, let's create a new button. So I would say new code added to create a button. All right, and over here to create a button, I would simply say button is going to be QPushButton, and obviously we need to pass in self as a parameter here. And now in order to set the text on this button, I would say button.setText, and I would say something like click here. And now in order to add this button onto our layout, I would simply say button.move and then specify the X and Y coordinates. So let's say I want to place this button at 100, 200. I would simply add that. So now let's run this code. And if you take a look at the window, here is our button. So if I click on this button, nothing happens as of now because we have not yet added the mechanism to handle the events. So let's do that as of now. So now in order to go ahead and handle the click event associated with that particular button, what we need to do is we need to use the signals and slot mechanism. So according to the signals and slot mechanism, whenever we click on a specific button, an event is generated or a signal is generated, and then this signal has to be connected to a slot or a function or a method. So here first let's go ahead and let's capture that specific signal. So whenever I want to capture that signal, I would say button.clicked. So clicked is the event which we are kind of looking for, and then I want to connect it to a specific slot. So here I would say click.connect, and a slot over here is nothing but it's some sort of a function or a method. So here we want to connect it to a method, and that method is not yet defined. So let's create our own method here. So I'll create a method called as button clicked. Obviously this needs to accept self, and then over here I could do anything which I want. So let's keep this method as simple, and let's say this method only prints hello or button clicked on the console here. So here I would say print button is clicked, and that's it. So now once you have this particular method, we could use this particular method as a slot. So here for this button, when this button is clicked, I want to connect it to this method which is button clicked. So over here I would say self.button clicked, and as this is a class method, you have to say self.button clicked and not just button clicked. Alright, and now let's see what happens when I click this button. So if I go ahead run this, if I go back here, right now as you can see there's nothing in the console, but as soon as I click on this click here button, you'll be able to see that here we get button is clicked. If I go ahead and click this one more time, as you can see we got button clicked over here twice. So this is how an event is handled. So the way in which we have handled the event is that we have used the signals and slot mechanism, in which we are looking for the signal which is the clicked signal, and whenever that clicked signal is happening, we have connected it with a slot, and the slot here is nothing but this particular method which we have predefined up over here. So this is how event handling could be handled. Now let's say we want to go ahead and handle some more complex event, in which let's say we want to increment something on the window. So right now when we click on click here, everything is happening over here in the background, and the result is kind of being reflected in the console. But what if we actually want to change something over here? How exactly can we do that? So let's learn how that can be done in the next one. But even before that, let's fix one thing, and that is to go ahead and create a different function for initializing the window. So right now we are having the initialization logic right inside the constructor itself. But in this constructor, let's say I only want to go ahead and call the super method of this particular constructor and do nothing else. So let's go ahead and let's separate out this logic in the next lecture into a different method. So thank you very much for watching, and I'll see you guys in the next one. Thank you. In this particular lecture, let's go ahead and let's separate out the logic for actually calling the constructor of the superclass as well as this initialization logic right here. So this initialization logic which we have here is for our existing window, and we actually want to create a different method or a different snippet of code for this. So doing that is actually quite simple. What you do is you define a new method here. So over here, I would create a method called as init UI. So def init UI. This is going to accept self, and then let's have all of this code which we have for initializing the user interface in that method. So right now this automatically is inside this particular init UI method, but now the problem is if you run this code, this won't be initialized, and that's because this is a function definition. So now what we have to do is we have to call this init UI method whenever this constructor is executed. So over here, in order to call this method, I would simply say self.init UI. So all that we have done here is that we have simply taken out this code, put it up into its own very method so that these two things don't get mixed up. And as we want to call this particular method right after the super method is called, or the init method of the super class is called, we have actually called this up over here. Alright, so if you do that and if you run this code, everything should be working absolutely fine. And once you have this, that means this initialization part is working well. So remember that now we have two init methods. This init method is nothing but it's a constructor of this class, and this is actually calling the init method of the superclass itself. So therefore we have separated this out into its very own different method. And over here we have called this init UI method, which actually contains the code which we had previously. Now logically both of the approaches are exactly the same. However, the only difference between the first and this approach is that the code over here is much more organized. So the reason why we have organized the code in this manner is because as we move ahead, we will be writing some more complex programs, and it would be better if we keep these two things separate. So once we have kind of modified our code, in the next lecture, let's go ahead and let's try to add a label onto our window so that whenever we click this particular button, the count on that particular label should increase. So let's learn how exactly that could be done in the next one. In this particular lecture, let's go ahead and let's have a label onto our window. And let's say whenever we click this particular button, we want to increment the count which is set on that particular label. So let's first go ahead and let's add a label to our window. So here I would actually add a comment which would say something like adding label to display count. And just as we create any other label, let's create a simple label over here. So I would say the label is going to be equal to QLabel, and then let's pass in self, and over here I would say set the label's text to 0. So set text to 0, and this should be in quotations. And after this, after setting the text, let's move this particular label to a position so as to place it on the window. So label dot move, and move it to 100 comma let's say 150. Let's save this, and now if I run this, as you can see now I have this label right up over here. So when I click on this button, I essentially want to change the value of this label. So now let's learn how exactly that could be done. So first of all, in order to change the value of this label should not have some hard-coded text here, but instead it should have some sort of a variable to keep track of its count. So therefore, in order to do that, we need to create a variable in order to keep track of the number of times the label has been clicked. So over here, I could create a variable called as count. So I could say count equals 0. However, now the problem with this approach is that if I say count equals 0 in the init UI method, I cannot access this count variable over here inside the button clicked method which I have. Therefore, instead of simply saying count, I have to say self.count. So now this actually becomes an instance variable, and now I will be able to access that variable up over here as well. So now whenever the button is clicked, I want to increment the value of the count by 1. So over here I could say, all right, take the count, which is self.count, and increment the value of this thing by 1 every time the button is clicked. And then after the count value has been incremented, I want to take the label and set the label's text value to this count value which I have. So let's try doing that. So I'll take the label here. I would say label dot set text and then set the value of this count variable which I have, which is self.count. But even before setting the value of count directly over here, I need to convert this value to a string. So str of self.count. Alright, now you might think that this would work, but this won't work, and that's because we are trying to access the label which we have here in this method, which is the init UI method, inside some other method which is button clicked. And this won't be possible because this becomes a variable which is bound to this method. So we actually want to convert it to an instance variable instead. So we will do the same thing which we have done over here with this count. So over here, instead of simply saying label, I would say self.label, self.label, and self.label over here as well. So now what happens is this label would be accessible over here as well by saying self.label. All right. So now this might work. So let's see if this would work. So I'll go back, close this window, run this code one more time. And now if I head back over here, if I click here, as you can see, the count changed to 1. Click here one more time, the count changes to 2. If I keep on clicking, the count increments. However, one interesting thing happens when I click over here one more time when the count reaches 9. As you can see, we have 10 here, but this part is getting cut off. And this happens because whenever you have some sort of label here and whenever you set the text of that label initially, PyQt actually assigns it a specific size. However, if the value inside this particular thing increases, PyQt won't be able to go ahead and adjust the size accordingly. Therefore, what you need to do is, whenever you go ahead and change the value of the label using the set text, after doing this, you need to set the size or adjust the size of that label as well. So over here, I need to add another method called as self.label.adjust size. So if I do that, this will automatically now go ahead and adjust the size of label depending upon whatever text which we pass here. So let's run this code. And now if I click over here, as soon as the count reaches 10, as you can see, the size over here is self-adjusted and the text is no longer being cut off now. So this is how you could go ahead and update a certain widget in your PyQt window whenever an event happens. So once we have learned how to handle this basic event, in the next lecture, let's go ahead and let's learn how we could accept the input from the user in a PyQt application. So let's learn about that in the next one. In this particular lecture, let's learn how to accept some input data from the user so that that data could be further processed. Now, if you want to create some complex applications, managing events alone isn't sufficient, but a lot of times you will be accepting some kind of data input from the user as well. So in this lecture, let's write a PyQt application which accepts name from the user. So in order to create that application, let's make a couple of changes here. So in the init UI method, let's get rid of this code to create the button as well as adding the label, and we'll be creating a new label and a new button. And let's also get rid of this method as well, so that now you only have the initial code. Now in this particular init UI, let's first go ahead and create a label which actually asks the user to enter their name. So over here, let's name that label as name label. This is going to be a Q label. Let's pass in self here. And then let's set the text for this label. So name label dot set text, and let's set the text to enter your name. After that, let's add this particular label to the window. So we say name label dot move, and then let's move it to the coordinate position 60, 10. So after this, now in order to accept some name or some input from the user, there's a specific widget which we need to use in PyQt, and that particular widget is called as QLineEdit widget. So the QLineEdit widget allows us to go ahead and accept any kind of data from the user. So in order to use that widget, you first have to import it from the Qt widgets. So here I would say QLineEdit. And once that widget is imported, as that is a class, over here I will go ahead and I would say QLineEdit create an object of this class, and let's save this particular thing into a variable called as, let's say, name. So QLine edit, let's also pass in self here. All right. So now once this particular widget is created, the next thing which we could do is we could actually add it to the window. So here I could say name.move, and let's try to add it at the position which is, let's say, 60, 50. So once we have this widget, let's see how it looks like. So if I go ahead and run this code, and now if I go back over here to our window, as you can see, this is how the widget for accepting the input looks like. So if you take a look at this widget, you'll be able to see that the size of this widget is limited. That means it only spans this length right here. But what if you actually want to make this widget wider? So in order to set the size of the QLine edit widget, there's a special method which is called as resize. So over here, after creating the QLine edit widget, I could go ahead and say, all right, take the widget and resize it to something else. And to this resize, you need to pass in the width and height of the widget as you want. So let's say you want to set the width of this thing to 200 and the height to 20. I could simply specify that. And right now, if I go ahead and run this, that particular change will be reflected up over here into our widget. So now as you can see, the size of this widget is a lot longer. All right, so let's go back here and let's also set some different size over here for the window as well. Let's say 300 by 200. So let's make it a little bit smaller. And after adding the line widget, let's also add a button here so that whenever that button is clicked, our program should be able to go ahead, extract whatever data is entered by the user in the QLine widget and kind of display it in the output console. So I'll create a button here. So this would be a Q button. So Q push button, pass in self. And over here, I'll add some text to this button. So button.setText, and let's set the text to add. And after this, let's add this button to the user interface by saying button.move. Let's place it at position 200, 80. And then I would say button.clicked to check for the click event, and let's connect it to a method. So that method would be defined later. All right, so let's define that method here. So I'll go out of this particular init UI method and create our very own method here. So I would say def. Let's name this method as button clicked. This is going to accept self as a parameter, and this is going to do something. So let's say for now, this would say something like button clicked, and that's it. Now let's add that particular method here. So I would say self dot button click should be executed whenever we click this button. All right, so if I go ahead, run this code, go back here, this is what our window looks like. If I say Rob, and if I click on add, as you can see, it says button clicked. However, now our job is to go ahead and actually take whatever input is here inside this particular QLine edit widget and display it to the console. So in order to display this inside the console, we first have to go ahead and get access to this QLine edit widget and then get the text which is inside of it. And one more thing which we need to remember is that we need to access this name widget inside a different method here, which is the button clicked method. So the question is, how exactly would you do that? So in order to do that, instead of using name here, I have to use self.name every time where I want to mention this QLine widget. So what this allows us to do is, now it allows us to access this particular instance variable inside the other method as well. All right. So over here, now I could say print, and I could say that your name is, and access that name value here by simply saying self.name. So this gives us access to the QLine widget. And in order to get the text which is entered inside the QLine widget, you could go ahead and say self.name.text, and this will give me the text which is entered in there. All right, so let's see if that works. So I'll go back here, close this one, run this code one more time. And now if I go back here, let's enter some name like Jake. If I click on add, as you can see on the output, we got the result as your name is Jake. Let's change this thing to Sam. If I click on add, as you can see, it says your name is Sam. That means we are now able to go ahead and extract whatever name which we have typed in over here. Now what if you actually want to take this name and then display that name up over here within the window itself instead of actually displaying this name in the console? So in order to do that, first of all, you would have to add a label here. So let's do that over here as well. So I'll create a label here inside the user interface. So I would say label, and instead of just label, I would say result label. So result underscore label equals, it would be a Q label with a self, and then I would set the text of this thing, but initially we do not want to set the text of this label, so we will leave it as it is. And then let's move this label to the user interface. So I would say result label dot move, and let's move it to 60, 120. All right. Now after this, once the label has been created, we want to set the text of that label up over here. However, we all know that we cannot access the result label here as the scope of this particular variable is limited to this method itself. Therefore, in order to access this result label here, we need to say self.result label here and self.result label here as well. Now we could access that here by saying self.result label. And now if I want to change the text of this label, I would say dot set text and set the text to nothing but this code which we have here. So I could simply copy this, paste it up over here, and this should work well. So if I could go ahead, close this, and if I save and rerun this, it says enter your name, let's say Sean. Now you will be able to see that the text of the label actually changed, but it did not adjust its size, and it's kind of chopping off the rest of the text which we have here. So in order to solve this problem, we have to actually resize this particular label, or we have to set a fixed size for that label here. So right when we create the label, we could set the size of this label to something larger. So here I could say self.result label. That means take the label, resize it to something else, or instead of resizing, I would say I want to set the fixed size. So there's a method called as setFixedSize, which allows us to specify the width and height of this label. So let's set it to 150 and 20. All right. So this time if I run this, and if I go back here, if I type in John here, click on add, as you can see, this thing says your name is Sean. If I change it to Rob, now it says your name is Rob. This means now we are successfully able to go ahead and accept some input data from the user, which could be further manipulated. So in this case, we have simply accepted a string, but you could also go ahead and accept integers, floats, and other data types as well. So in the next lecture, instead of accepting name, let's write a program to accept two numbers, and then let's try to add them up together. So let's learn how to do that in the next one. In this particular lecture, let's go ahead and let's write a PyQt program to accept two numbers from the user and then add them together. So in order to create this program, let's go ahead and let's get rid of this code which we have, which is let's get rid of the count variable. Let's get rid of the different labels which we have, except for the label to resize the window. All right. So once we have this, now let's go ahead and let's define a couple of things. So as we want this particular app to accept two numbers, let's first go ahead and create a couple of labels here. So in order to create those labels, I would say num1 underscore label, and this is going to be a Q label. So let's pass in self here. So I could say self, and instead of using set text, I could directly pass in the text which I want on this label right up over here. So I could say something like enter first number. Now let's go ahead and let's resize this particular widget. So here I could say num1 label dot, that's going to be resize, and I'll resize it to 200, 20. And then let's move it to a specific position. So num1 label dot move it to the position 20, 20. And after this, let's also go ahead and in front of this particular label, let's also have a QLine edit widget to accept the first number. So over here, I could say num1 underscore input as the name of the QLine widget. So num1 input is going to be QLine edit, pass in self here. And after this, let's add it to the widget as well. So num1 input dot, that's going to be move, pass it to the position 200, 20. So now if I save this and if I go back and run this code, as you can see, this is what our window looks like. So we need to resize the window over here as well. So in order to resize the window, I'll go ahead and set a different size for this window. So let's set it to 400, 150. That would make more sense. So now if I close this, go back here and rerun this one more time, as you can see, this is what our window looks like, and that's absolutely fine for our requirements. So now once we have the basic setup done, now let's go ahead and let's create a second label over here as well. So in order to create the second label, I'll simply copy all the code which I have here, paste it up over here, replace num1 to num2. Let's make those changes everywhere. And let's do the same thing for the input as well. So num2 input and num2 input. I would say enter the second number. Over here, let's change the coordinate points of this one. So from 20, I'll set it to 70, or let's say 60. So after this, let's go ahead and do the same thing over here as well. And once we are done with this, we are pretty much good to go. So after creating the second label, I could run this code just to make sure everything is working fine. So enter first number, enter second number, and I guess we have misspelled number here. Let's fix that. This should be number and number. So after adding this, let's now go ahead and let's add a label to display the result variable over here. So here I could say result label. So result underscore label is going to be Q label. Let's add the text as result. And for now, this is going to be empty. Let's pass in self over here to this particular widget as well. And now let's move it to a specific position on the UI. So result label dot move 20, 100. So after having the results label, the final thing which we need to have here is the calculate button. So here I'll create a button called as calculate underscore button. This is going to be Q push button. This would say something like calculate, and let's pass in self here. And after this, let's move it to a specific position on the UI. So calculate button dot move, and let's move it to 200, 100. After this, we now need to attach the signals and slot mechanism to this button so that whenever this button is clicked, the method to calculate the sum of these two numbers should be executed. So here I would say take the calculate button dot clicked. So clicked is the signal which we are looking for, and we are going to connect it with a method. So connect, and then specify the method over here with which we want to connect it to. So let's define that method up over here outside the init UI method. So here I'll create our very own method called as calculate sum. Def calculate underscore sum. Obviously this would accept self. And in this particular method, the first thing which we want to do is we want to get the text, whatever text is entered inside this num1 input and num2 input. So let's get those numbers here. So I could get the first number by saying num1 is going to be self dot num1 input. So num1 input dot text. So this gives us whatever data is being entered there. And then after getting this data, we want to convert this string data into a floating point number. So therefore, I'll use a float here and then pass in whatever number which we have up over there, because obviously whatever data which you enter here is going to be in form of a string. So that string needs to be converted into a float or an integer even before you go ahead and add that. All right, so let's do the same thing with the second number as well. So this would be num2 self dot num2 dot input dot text, convert it to float. And finally, once we have these two numbers, I could create a result variable, and I would say num1 plus num2. So the reason why we are not using self here is because these are local variables. However, there's one thing which you need to understand here. As we want to access num1 and num2 inputs over here inside the calculate function, we also need to refer to those particular inputs using self over here and over here. So I have to say self here, self here, self over here, and self over here as well. And the reason why we need to use self for the edit and not for the labels is because you don't want to refer the labels over here. But as you need to refer to the num1 input and num2 inputs here in the other method, you have to use self along with this. And also, after getting the result, you also need to set the result label to that particular new result or the result over here. So that means you also need to set this result label to self. So self.result label, self.result label. And after this, I could go ahead, take the result label and set it equal to the result which we have. So self.result label dot set text and set the text to a string. Now over here, I'll make use of f strings. So I could say results and then simply add a result here. So this result is nothing but this value right here. So I could say result and then dot 2f so as to format it in a better way. All right, so after this, we want to trigger this method whenever the button is clicked. So here inside connect, I would say self.calculateSum. All right, so now let's test this code and see if it works. So I'll run this code now. Let's head back over here. Let's enter the first number as 10, second number as 20. If I click on calculate, there's a result here, but that result is not displayed, maybe because this label is not resized. So therefore, we also now need to go ahead and add the resize code for that particular label as well. So I could go back here and I could say self.resultLabel.resize, and let's resize it to some width, which is, let's say 300, 20. Hopefully that works. So let's get back here, close this. Let's rerun the app one more time. Let's go back here. 10, 20, calculate, and as you can see, the result is displayed up over here. And this .2f which we have here, it kind of displays the 2 decimal points which we have up over here. That's because sometimes when you have decimal points over here, then those decimal points would be trimmed up to only have 2 values or 2 digits after the decimal point. So now let's try something else like 220. That gives us the result as well. Let's try with some decimal values. This gives us an accurate result as well. However, let's see what happens when we have one of the values as strings here. So if I click on calculate, the program over here crashes, and that's because you cannot go ahead and accept a string over there. So now in order to solve this particular problem of the program crashing whenever we enter a non-numerical value, is that we could add exception handling to our code. So over here, the snippet of code which might cause an exception is this snippet of code right here. And therefore what we would do is we would actually enclose this entire snippet into a try block. So let's take all of that code here and let's shift it 1 indentation level to the front. And along with the try, let's have the accept block. And we want to accept the value error. That means whenever the value is invalid, in that particular case, what we wish to do is we wish to catch that error. And in the label, we want to say something like, all right, you have entered some invalid input. So over here, I could say, take the label. So self.result label, set its text to something like invalid input. Please enter numbers. So now if I save this and if I run this code, now our program won't crash when someone tries to go ahead and add some text here. So if I add some text here and click on calculate, it says invalid input. And this is not resized because you actually need to include the resize code here. So let's include this over here as well. So now if I again close this, rerun this one more time, let's try entering some invalid values. If I click on calculate, it says invalid input, please enter numbers. You could also shift this button to a little bit right so that these two things do not overlap. That will work really well. And now let's try entering some numbers here like 100, 200. If I click on calculate, this time it produces an accurate result and the program didn't even crash. So this is how you could go ahead and write a PyQt program to accept 2 numbers from the user and then calculate their sum. Now in the next lecture, let's go ahead and let's learn about a checkbox widget. So let's learn about the checkbox widget in the next lecture. In this lecture, let's go ahead and let's learn about the checkbox widget in PyQt. So a checkbox widget is nothing but it's some widget which could hold one of two values, which could be on or off button. So you could say that a checkbox widget is like a switch, and that switch could either be on or off, and it could only hold the on or off data. Now when we click the checkbox widget, we typically do not say that we have clicked that particular checkbox widget, but instead we say that we have toggled it using toggle. So in case of a checkbox, we have the toggle event instead of the click event which we usually have. So in this case, whenever you have to associate some action with a checkbox widget, in that particular case, you have to go ahead and use the signal which is called as toggle. So let's go ahead and let's take an example to understand the checkbox widget in a much more better way. So over here we have the code from the previous lecture, which is the init UI code as well as this calculate method. So let's get rid of the calculate method from here, and let's also get rid of all the other code which we have from the init UI method, except for the code which actually sets up the window. So let's get rid of this label from here. And over here, let's say we actually want to design a program which kind of tells us if we want sugar in our beverage or not. And we are going to be setting that particular option using a checkbox. So in order to create a checkbox, what you have to do is you have to import the QCheckbox widget from the PyQt.Qt widgets class which we have. So over here, I simply have to say, all right, I need to import the QCheckbox. So this QCheckbox, if you hover over it, it's actually a class, and we have to create the object of this class. So in order to create that object, let's go back here in the init UI method itself, and I would say that, all right, I want a checkbox which checks for the presence of sugar. So let's call this particular checkbox as sugar underscore checkbox. This is going to be an object of the QCheckbox class which we have imported. So over here I'll pass in self, and as usual, as we set a text for the label, this checkbox also need to have some sort of a text as well, or else it's going to be empty. So here I would say sugar checkbox dot set text, and let's set the text of this thing to sugar. So that means now whenever we check this particular checkbox, that means we want sugar, and whenever we uncheck this particular checkbox, that means we do not want sugar in our beverage. So let's add this checkbox to our main window or our user interface. So I would say sugar checkbox dot move, and let's move it to the position like 20, 40. And after this, we now want to associate an event handler along with this checkbox. So therefore I would say sugar checkbox, and here the signal or the event which we are looking for is not clicked, but instead, as this is a checkbox, we need to use the toggled event. So here I need to say toggled, not toggle. Remember that you have to use toggled here. So that means whenever this checkbox is toggled, I need to connect it with a slot. So connect it with a slot, which is going to be a method. So we are going to define that method here. So let's define that method up over here, and let's call this method as sugar checked. That means we have checked off the sugar checkbox. And now in this particular method, obviously this method needs to accept self as a parameter. But along with this, there's also one additional parameter which this particular method needs to accept. And that particular parameter is the checked itself. So this checked kind of gives us an idea if the checkbox is checked or not. So let's accept checked here. And now over here, what I could do is I could check if this checked is true or false. That means if this checked is true, that means the checkbox has been checked. And if this checked is not set to true, that means the checked is false. So over here, I would say, all right, if checked is true, that means I need to say something like, all right, the sugar is checked. So I'll simply print something to the console, which would say something like sugar added, or else that means whenever checked is false, I want to say print sugar not added. And that's it. So once we have this checkbox, we are pretty much good to go. So now let's see how that would work. So even before running this code, let's now attach this particular method as a slot over here to this toggled signal. So here I could say self dot sugar checked. All right. So now what happens is this checkbox is going to be created. It's going to be added to the user interface. Then we will associate a signal and slot with this so that whenever there's a toggled signal, that means whenever the checkbox is toggled, this method would be executed. And this method would also accept the checked as well. That means if this checkbox is checked or not. Whenever this checkbox is checked, the code inside the if block would be executed, and whenever this is not checked, in that case the code inside the else block would be executed. So let's see this in action. So I've actually saved this code right now, and if I run this, now I have this window right here, and as you can see right now, this is not checked. So right now there's nothing being displayed here. However, if I click on this, now this checkbox is toggled and the sugar is checked. And as soon as the sugar is checked, it says sugar added. Now if I go back and uncheck this, it says sugar not added. If I go back, toggle this thing up again, it says sugar added one more time. So this is how the basic checkbox mechanism works. Now let's say when we toggle this particular checkbox, instead of printing something to the console, let's say we want to display the changes over here itself. So in order to do that, we have to go ahead and add some kind of a label to our checkbox. So over here, I'll simply go ahead and create a label. So in the init UI, I'll create a label. So I would say self.label, and the reason why we are using self here is because we want to use this label in this particular method here. So this is going to be a Q label, accept self as a parameter, then say self.label.setText, and let's initially set the text of this thing to, let's say, empty. And then over here, I would go ahead and also resize this as well. So self.label.resize and resize it to 200, 20, and then let's move it to a position as well. So self.label.move to a position 20, 90. Now once we have added this label, now we wish to change the text of this particular label whenever this option is checked. So if the sugar is checked, I actually want to go ahead and take the label. So self.label, which takes that label, and then I would say set the text of this thing to the sugar added, or else I would say take the label. So self.label, set the text of this label to sugar not added. And that's it. You could also get rid of these print statements from here as well. So now let's run this code one more time. And right now, if you take a look at this, this is the checkbox. Right now the label is empty. However, when I check this, it says sugar added. And whenever I uncheck this, it says sugar not added. However, if I toggle this checkbox one more time, it again says sugar added one more time. So this is how the checkbox widget works, and what this checkbox widget allows us to do is that it allows us to set a particular condition on or off in a given program. So once we have understood the basic mechanism of a checkbox, in the next lecture, let's go ahead and let's write a complex program which helps us to calculate the cost of a coffee depending upon the different ingredients which we add to our coffee. So let's design that interesting program in the next lecture. In this particular lecture, let's go ahead and let's write a complex program which calculates the cost of your coffee depending upon the ingredients which you want to add to the coffee. So in order to create this particular program, let's go ahead and let's get rid of all the code which we have from the previous lecture. So let's get rid of this particular sugar check method which we have. Let's also get rid of all the other code in the init UI except for this particular part which sets the UI. So over here, the very first thing which we need to do is we need to create a variable which tracks the cost of the coffee. So over here, I would say the total cost of coffee would be this variable. And now as this variable needs to be accessible to all the other methods which we have in this particular app, here what we wish to do is we wish to say self dot, let's say total underscore cost. And let's first initialize this total cost to 0. Once we have this, now let's go ahead and let's add a label which would ask the user to select the options they want. So for that, let's create a label which is going to be a Q label, pass in self here. And then let's set the text for this label. So label.setText, and let's set the text to select your options. After that, let's resize this label. So I would say label.resize, and let's resize it to 200, 20. Now let's add this particular label to the window. So label.move, and let's move it to the position 20, 20. All right. So after this, now let's add a couple of checkboxes. So let's say the coffee which we are trying to make here have the option to add milk and sugar. So here, first of all, let's add a checkbox for checking the sugar. So here I would say sugar underscore checkbox. This is going to be Q checkbox. Pass in self here. And after this, let's set the text for this sugar checkbox. So I would say sugar checkbox dot set text, and this would say sugar, and let's also display the price which would be increased if we add the sugar. So let's say if we add sugar to our drink, that particular drink is going to be costlier by $0.5. So I'll add that up over here. And then let's add this particular sugar checkbox to the user interface. So sugar checkbox dot move. Let's move it to the position 20, 40. Then we need to attach this particular checkbox to a slot using the signal and slot mechanism, but we are going to do that later. But before that, let's go ahead and let's also add a particular checkbox here for milk as well. So here I'll say this is going to be milk underscore checkbox. This is going to be a Q checkbox as well. So Q checkbox, pass in self, and then milk checkbox dot set text, and set the particular text of this thing to say something like milk. And let's say if we add milk, the coffee is going to be costlier by $1. So I'll add $1 here as the text. Now let's also add this milk checkbox to the window. So let's move it to the window at position 20, 60. All right. So once these two checkboxes are done, now we have to go ahead and associate these two checkboxes with their own slots. So over here, I want to say that, all right, whenever the sugar checkbox is toggled, then I want to execute a specific method. Therefore, I would say sugar checkbox dot toggled, and make sure that you don't select toggle, but instead you select toggled. So whenever this is toggled, I want to execute a method. And same is the case with this milk checkbox as well. So milk checkbox dot toggled, I want to execute another method here. Now remember that the methods for the sugar checkbox and the milk checkbox are going to be different. So now let's go ahead and let's define the method as to what happens when the sugar checkbox is toggled. So make sure that you're out of this particular init UI method and you're actually present up over here. So let's define that method here. So let's call this method as sugar checked. So dev sugar underscore checked. This is going to accept self as well as checked, and this checked kind of gives us an idea if this particular checkbox is checked or not. So here we'll make a check. If it is checked, then perform some action, else perform some other action. So for now, I've actually written pass here. So now let's attach this particular method with this toggle action. So sugar checkbox dot toggled dot, that's going to be connect. That means connect this particular self dot sugar checked method. All right. Now let's do the same thing with this milk checkbox as well. But even before that, let's first complete this method. So if this thing is checked, that means whenever the sugar is checked, that means our customer actually wants sugar in their drink. And if they want sugar, then we have to add this $0.5 to the total cost which we have. So over here, what we need to do is, if the sugar is checked, we simply have to say, all right, take the total cost. So self.total cost gives us access to this particular total cost which we have. Now you might have understood why we have used self over here, because if we wouldn't have used self over here, then we wouldn't be able to go ahead and access that variable here. So simply go ahead, take the total cost and add a 0.5 to it. Or else if that's not the case, that means if the sugar is not added to the drink, then we need to subtract this cost from the drink. So therefore I would say self.total cost minus equals 0.5, and that's it. So now what happens is, whenever I check this particular sugar checkbox, the cost of that particular sugar would be added. And whenever the checkbox is not checked, it will go ahead and subtract or remove that particular sugar cost from the total cost of the sugar. All right. So now let's do the same thing with this milk checkbox as well. So let's define another method here for adding milk. So over here I would say def milk checked, accept self as a parameter, also accept checked as well, so as to see if the milk checkbox has been checked, and if it is checked, then perform some action, else perform some other action. Alright, now let's attach this milk checked method to this particular checkbox. So milk checkbox.toggle dot, that's going to be connect, and connect the milk checked method. This should be checked. And also don't forget to have self here, because you cannot directly access that method here, but instead you have to say self.milkChecked. So if the milk is checked, that means I now need to add 1 to the total cost. So I'll again use the same code which I have here, but instead of incrementing the value by 0.5, I now have to increment the value by 1. And the same thing applies over here as well. That means whenever the milk is not checked, that means I now need to subtract 1 from the total cost of the milk. So now once everything is done, there's one last thing which we need to do. And that thing is, we need to display the total cost of our coffee or our beverage onto the main window which we have. And therefore we also need to add a label at the end as well. So let's add another label here. So I'll call this thing as result underscore label equals, that's going to be a Q label. Let's pass in self here. And then once we have this particular label, let's add it to the window. But even before that, let's add some text to this particular label. So result label dot set text. Let's set the text of this label to total cost is, and then $0. So initially the total cost would be 0. And then let's resize this label as well. So result label dot resize, and let's resize it to 200,20. And then let's move it to the window as well. So result label dot move at position 20,90. So now the label is added here, but now we want to change the text of this particular label in these two methods which we have here. So whenever the total cost of a particular drink changes, if we check or uncheck milk or sugar, in both the cases we want to go ahead and actually change the cost of this label which we have. So in order to do that, what we could do is, we could go ahead and go inside this particular method, and we want to say that, all right, take the total cost, whatever we have, and then change the label which is result label. But now the problem is, the result label is actually present in this init UI method. Therefore, in order to make it accessible to both of these methods, we have to use self here. So self.result label, make sure that you use it on all the lines. So self.result label over here and over here. So once we have this result label accessible in both the methods, there are two ways of actually changing the result label here. One way of changing is that you could go ahead, change that here and change that up over here as well in the if as well as else, but it's actually better if we change the result label at the very end when one of these actions has occurred. So I could go ahead and over here I could say, take the result label, so self.result label, and then set the text to total cost, and then have a $sign here, and then get the total cost from here. So in order to get the total cost dynamically, I could say, all right, self.total cost. However, this self.total cost which we get here is going to be in form of an integer. Therefore, we first need to convert it into a string. So I'll include this into a str, and after getting this str, I would append this str or strings to the initial string which we have. And the same thing needs to be done over here as well. So I'll copy the same code and then paste it up over here as well. So let's see if this thing works successfully. So I'll go ahead and run this code. And as you can see, this is what our application looks like. So right now the total cost is 0. If I add sugar, the total cost is $0.5. If I add milk, the total cost is 1.5. If I remove milk, the cost gets back to 0.5. If I remove sugar, the cost gets back to 0. And then if I select milk, sugar, and just remove sugar, the cost comes back to 1.0. So this is how this dynamic application works, and this is how dynamically it calculates the cost of our drink. Now the basic cost of our drink without the sugar and milk was set to $0. However, you could change it according to your own needs. So this was just to show you how you could go ahead and make use of checkboxes to design a dynamic application which could change data in real time. So that's it for this lecture. And in the next lecture, let's learn about another interesting widget, which is the Q message box widget. So let's learn about that in the next one. In this particular lecture, let's learn about the Q message box widget in PyQt. So as the name signifies, the Q message box widget is used to display some kind of a message to the user. So let's say, for example, if the user is interacting with your PyQt application and you want to display some kind of a message to that particular user, and the user could then be able to go ahead and interact with this pop-up by clicking on a button. So this is what the Q message box widget does. Now, in order to understand what this Q message box widget looks like, you could imagine a pop-up which you get when you try to go ahead and close a file without saving. So in that particular case, you don't just get the message, but you also have the ability to interact with that particular message as well. So for example, you could say that, all right, I want to save the file, you want to exit, or you want to cancel that particular option. So this is what the Q message box widget allows us to do. So let's go ahead and let's take an example of a Q message box to understand it in a much more better way. So the very first thing which we would do here is that instead of using a Q widget, let's actually convert our application into a window. So instead of displaying a widget here, let's say we want to now inherit from the Q main window class. So I would say Q main window. And we also have to actually import this particular Q main window as well. So over here from this, I want to import the Q main window along with the rest of the widgets which we have. So now let's go ahead and let's make use of the Q message box widget. So I'll also import that over here as well. So Q message box, we have imported that widget here. And let's say instead of directly popping up this widget when we run our application, let's say we have some sort of a button on our user interface which will pop up the Q message box for us. So in order to pop that up, let's first go ahead and get rid of all the code which we have from the previous lecture, except for the initialization part. And over here, let's add a button. So this is going to be our regular Q button or Q push button. And let's say when we click this particular button, we want to open up the message box. So here I would say show message box as the text for this particular button. I'll also pass in self. So the advantage of passing this message right up over here is that you don't have to use set text for this button. So after doing this, now let's go ahead and let's place this particular button onto the window which we have. So here I would say button.move. And let's place it onto the position like 200, 40. And now whenever this particular button is clicked, let's say we want to perform some action. So here I would say, all right, when we click on this button, so button.clicked.connect, connected to a method. So let's define that method here. And the method which we want to define here should be able to go ahead and open up that Q message box for us. Therefore, let's name this method as show message box. So def show message box, pass in self here. And then we now need to go ahead and create a message box out of this class which we have. That means here we need to create the object of this. So I would say Q message box. Let's name that object as MSG to keep things simple and short. And then we actually have to go ahead and set the title for that particular message box which we have. So whenever you have a message box, that message box is sort of like a widget which you already have in your application. So as your widget actually has a title, this message box needs to have a title as well. And in order to set the title for that message box, I have to say msg dot, that's going to be set window title. And over here, I would set a title like, let's say message box title. And then we also need to set some text for that message box as well, which is the actual message. So here I would say msg dot set text to set the text on this one. And I would say this is a simple Q message box. Now the next thing which we need to do is that we want to set some kind of an icon for this particular message box. So let's say this message which we are showing up over here is an informative message. Therefore, you could have an information icon for that particular message. So here I have to say message box dot set icon. That actually sets the icon, and you don't have to worry about downloading an icon here. You could directly go ahead and access that icon from the Q message box itself. So you could say Q message box dot icon dot, and here as you can see you have a whole bunch of options like question. So if you want to ask user a question, you could use this option. If you want to display some information, use this information icon right here, or if you want to display some warning, you could use the critical one. So for now, let's go with the information one. So this actually adds the icon to the message box. So after adding the message, let's now go ahead and let's set the buttons which we want to have on this particular message box. So as I earlier mentioned, the message box not just displays a simple message, but it kind of acts like a dialog box wherein the user could actually interact by pressing certain buttons. So let's say on this particular message box, you want to have buttons like OK and cancel. So here I could say msg dot, and there's a method called as set standard buttons, and this allows us to set the buttons for the message box. Now in here, you cannot simply pass in some strings like OK and cancel, but you actually have to choose the specific options. And in order to access those options, it's already showing you that, all right, you need to have the buttons from this particular Q message box dot standard button. So let's type that thing in. So here I would say Q message box dot standard button. So let's type in standard button, and over here I would say dot, and here it will also give me access to the different buttons which we have. So from this we want the OK button. And after this, if I want to display or add another button here to the message box, I could say or, and then Q message box dot standard button. And from the standard button, I want to choose the cancel option. So here we also have cancel as well. And also over here, this S should be in capitals. So make sure that you remember that these things are case sensitive. So here we have the title for that particular message box. We also have the text, we have icons, we also have the options over here as well. And then let's say we also want to add a default button for this particular message box as well. Therefore, I would say msg dot set default button. And let's say the default button which we want to set for this one is going to be OK. So Q message box dot, that's going to be standard button dot OK. So once we have set the default button as well, we could finally go ahead, connect this particular message box with this button right here. That means whenever the button is clicked, this message box would show up. So therefore over here, I would say, all right, connect this with this method. So I would say self dot, that's going to be show underscore message underscore box. So till this point, everything almost seems accurate. So let's give it a try and see how it works. So if I run this, right now we get a window which says show message box. The message is kind of going out of the button, so we are going to fix that later. But for now, if I click on this one, as you can see, nothing happens. So if I click on this one, there's no warning or anything popping up over here. So let's close this for a second and let's see what exactly went wrong here. Alright, so for this particular button, instead of having button.move, let's say we use a method called as set geometry in order to add it to the window. So over here I could say button.set geometry, and over here I could also define the coordinate points of this particular button as well. So let's say 150, 80 are going to be the X and Y coordinates, and let's now set the width and height of this button as well as 200, 40. Alright, so after this, once the message box has been set up, in order to display this particular message box, you have to say the message box.exec, and this actually adds it to the main loop. Now this message.exec, what it does is that it gives us back some kind of a result which we are going to capture later, but for now let's simply run this app. And now once the app is up and running, this is what you'll be able to get. So if I click on show message box, as you can see, this is the pop-up which you get. So we have an icon over here for the information. We also have that this is a simple queue message box. Now you have an option to cancel or click on OK. So if I click on cancel, nothing happens. If I click on OK, nothing happens either. But let's say if you want to perform some different actions whenever we click on cancel or OK. So whenever we say message.excc, it creates that particular message box, and whenever we click the cancel button or the OK button, that result gets returned by this particular method right here. So let's capture that result into a variable called as result. So result equals this. And once we have the result, depending upon the result, let's say we want to display different things to the user. So here I would say, all right, if the result is equal to OK. So instead of simply equating it to an OK string, I have to say if this is equal to queueMessageBox.standardButton.OK. So I'll copy this and I would say if result is equal to this, then I want to print something to the console. So I would say OK button is clicked, or else if this is not the case, or else I want to print cancel button is clicked. All right. Now let's go ahead, let's save this code and run this. So as you can see, the application is up and running. If I click on show message box, the message box is popped up. And now if I click on OK, it says OK button is clicked. So if I now click on cancel, now it says cancel button is clicked. So depending upon whatever input the user provides, we could go ahead and perform some action here. So this is how the queue message box works, and this is how it actually helps us to kind of provide a pop-up to the user whenever some action happens. And this also allows us to go ahead and accept an input from the user as well. So in the next lecture, let's try to go ahead and let's try to take a real world example of this message box by writing a program which calculates square root of a number. So let's say, for example, we want to calculate square root of 49, and the square root of 49 is 7. So for some numbers, we get a proper perfect square root. But let's say, for example, if a user tries to enter a number for which the proper square root does not exist, then in that particular case, let's say we want to give them this pop-up which would say something like this number is not a perfect square. So let's implement that particular program in the next lecture. In this particular lecture, let's write a PyQt program which accepts a number from the user and it gives the user back the square root of a number. So even before developing this app, let's try to understand what a square root of a number is for those of you who do not have a mathematics background. So let's say if you have a number like 7, and if you want to calculate the square of this number, the square of the number 7 is nothing but 7 multiplied by 7. So the number multiplied by itself kind of gives you the square of a number. So 7 multiplied by 7 is 49. Therefore, we could say that the square of a number 7 is 49. And if we talk about things in reverse, let's say if you have a number 49 and if you want to calculate the square root of that particular number, the square root of that particular number would be 7. So this is what exactly square root is, and this is exactly what we will be finding out in this particular program. So let's go ahead, and in order to create this particular program, let's get rid of all the code which we have from the previous lecture. So let's delete everything from the initialization method. Let's also delete this show message box as well for now. And here we have the bare bones code. And over here, the first thing which we need to do is we need to have a queue line edit as well as a label which would ask the user to enter a number for which the user wants to calculate the square root. So first of all, I'll create a label here called as number label. This is going to be a queue label. And then let's ask the user to enter a number. So I would say enter a number, and then let's pass in self here. Let's add this particular label to the window. So here I could say number label dot move, and let's move it to a specific position like 20, 20. After this, let's accept the number from the user by using the queue line edit widget. So here I'll create a number input. So number underscore input equals, that's going to be queue line edit. Pass in self here, and now let's place this particular queue line edit onto the window. So over here I could say number input dot move it to the position which is 200, 20. And after this, let's finally have a button so that whenever we click that particular button, the result is calculated. So over here, I'll create a button called as calculate underscore button. This is going to be a Q push button. So Q push button. Let's say this would say something like find root. Also, we need to pass in self here. Let's now add the calculate button to the window. So let's move it to the position which is 200, let's say 60. After this, the final thing which we need is that we need a label, and this particular label should be able to display the final result. So here I'll call this label as result label. This is going to be a Q label, which would say result, and then have some space here, also pass in self here. Now let's move the result label to the window. So let's move it to the position 20, 100. So now once we have the basic layout, let's take a look at the layout and see if it looks well. So I'll run this code. And if you take a look at the layout, this is what the layout looks like. And that's exactly what we want. So over here now, if I enter some number like 49, and if I say find root, it should give me the answer as result as 7. So now let's go ahead and let's write the logic for that. So in order to write that logic, first of all, we have to use some signal whenever this calculate button is clicked. So over here, I would say, all right, take the calculate button, and whenever the calculate button is clicked, then connect it to a method. So we are going to be defining that method up over here. So let's create that method, and let's call this method as calculate square root. So def calculate square root, pass in self here, and all this method does is that it first of all takes the number which is entered by the user in this number input. So over here I would say, all right, take this number input, but if I want to access the contents of the number input inside this method right here, that means I need to make the number input as an instance variable. So therefore I have to say self.number input here and self.number input here, and only then I could go ahead and access that particular here. So here I could say self.number input, and in order to get the text from this particular input, I would say dot text. Now whatever text which we get here, this is going to be in form of a string. Therefore, first of all, we need to convert it into an integer or a floating point number. So let's convert it into a float, and after converting that, let's save it into a variable called as number, and that's it. So now let's go ahead and let's try to calculate the square root of this number. So in order to calculate square root of a number, you could go ahead and make use of the math module in Python. So let's go at the very top and import the math module. So import math, which is a module, and this math module actually has a method in order to calculate square root of a given number. So here I simply need to say math.sqrt, which is used for calculating the square root. So as you can see, this is a function. And over here, I simply have to pass in the number. Let's save this number into some variable like square underscore root equals this. So once we have this particular result, the final thing which we need to do is we simply need to take whatever result which we have and then assign this particular result to the label which we have. So the label which we have here where we have to display the result is this result label. And again, there's the same problem with this result label, and that problem is you cannot access this result label here. So that means you also need to convert this result label variable into an instance variable. Therefore, I would say self.result label and self.result label. Now I could access it over here by saying self.result label, and then I have to take this square root value which I got from here and then assign it to this result label. So result label dot set text, and set the text to something like, let's say square root of a number is this. So here I'll use an f string and I would say square root is, and over here I could simply go ahead and access the value of square root. So here I would say square underscore root. So now once we are done with this, now let's see if this works. So here let's connect this calculate square method with this button click.connect. So here I would say self.calculate square root, and that's it. So if I run this code, if I open up the application, let me enter a number like 49. So if I say find root, now it says square root is this. Let's try some other number like 81. It says square root is 9. However, what happens when we try to go ahead and find a square root of a number which is not a perfect square? So let's say, for example, if I say 34, as you can see, we get the result as 5.83. So in such cases, whenever we do not have a perfect square, in that particular case, what we wish to do in our program is that we wish to give a warning or a pop-up to the user which would say something like, alright, this particular number does not have a perfect square, therefore try with some other number here. So in order to give that particular pop-up, first of all, we need to go ahead and ensure that whatever number which we get over here, it actually has a perfect square. So the question is, how exactly will we be able to know that whatever square root which we are getting here, that's actually a perfect square or not? So in order to make a check, you might have already understood that a perfect square is nothing but if we go ahead and say something like 81, this gives us an accurate 9 and there's absolutely nothing after the decimal point. However, if we calculate the square of a number like 80, we do have some decimal digits up over here. That means now we need to go ahead and check if this result which we are getting up over here, if that is an integer or not. So therefore, in order to make that check, what I have to do is I have to say if the square root dot is integer, and what this is integer method does is that it checks if this particular number is an integer, and if that's an integer, in that particular case we want to go ahead and then perform some kind of an action. So if this is an integer, only in that case we want to set the value of the label to the square root, or else what we wish to do is that we wish to go ahead and we wish to raise a pop-up or a queue message box which would give a warning and say that, alright, this number is not a perfect square, so you could try another number. So over here I'll write an else block, and in the else block I'll create a queue message box. So queue message box, and the kind of message box which we want to create here is going to be warning, because we want to warn the user that this number does not have a perfect square. So over here I'll pass in self and then give a message like not a perfect square. And after adding this particular queue message box, we actually need to go ahead and save this particular message box into something. So let's say MSG is the variable name. Alright, so after adding this not a perfect square, you need to understand that this is going to be the title of the message box which we have. However, after this, we also need to go ahead and give the actual message as well. So here I'll add the actual message by saying the number is not a perfect square, and that's it. Now once we have this particular message box, let's see if this message box would pop up whenever we try to enter a number which is not a perfect square. So I'll run this code, and first of all let's try with a number like a perfect square like 81. This time we don't have any problem. However, if I say something like 80, if I click on find root, as you can see, we get a warning here which says that the number is not a perfect square, and that's exactly what we wanted as well. So over here, if I again go ahead and try with some perfect square like 36, this time I get the answer here. However, if I try with a number which is not a perfect square, in that particular case, I get the result as this number is not a perfect square. That means this particular dialog box is raising a warning in a perfect manner. Now another thing which we need to do here is that, let's say if the user actually enters some text here. So if they enter some text here and if they click on find root, in this particular case as well, the program crashes. And we want to prevent this crash from happening and instead actually raise a dialog box or a pop-up which would say something like, please enter a valid number instead of text. So in order to perform that, what we could do is we could actually enclose this entire thing in a try block. So here in this particular method, I would say try and then take all this code and then shift it one indentation level to the forward. So if I shift it by using tab here, now this actually becomes a part of this try block which we have. This try block should also have an except block as well. So at this line, I have to say, all right, except this. That means if any kind of exception occurs in this case, this needs to be handled here. So the way in which we handle this exception is we could go ahead and we could say that, all right, if this does not happen, that means if the number which we have entered here is not valid, we want to raise a value error. So here I would say accept the value error, and then over here I want to use the queue message box. So over here I could say create a queue message box which would say something like it's a warning. So let's pass in self here. Let's set the title as invalid input, and then let's give a message like please enter a valid number. So let's save this, and if I save this, go back here, run this code. Let's try to go ahead and crash this program by typing some text here. So this time if I do that, click on find root. Instead of the program crashing, now the dialog box says please enter a valid number. If I click on OK, now this gives me a chance to enter a number. So if I say 27, this time, as this is not a perfect square, it does not calculate that. However, if I try with a number like 64, it says that the square root is 8. So this is how you could go ahead and make your program more robust by adding some occasional checks here for validating the inputs as well as validating if that particular program produces the correct result. Now, one more check which you could add here is that you could go ahead and add an if block over here to check if the number entered by the user is a positive number or not. So you could do that on your own as well by simply adding an if statement after this line of code here. So this is how we could go ahead and use the queue message box in a way which helps us to develop applications in a much more robust ways. Now there could be multiple use cases of this queue message box as well, so you could explore them as well, but it's highly impossible to cover them all in a single course. So that's it for this lecture. And from the next lecture onwards, we will be learning about layout management in PyQt. So till this point, we are actually creating simple layouts, and we are only using the move method to actually place elements onto our window. However, there are better ways of designing layouts in PyQt, and that's exactly what we will be learning from the next lecture onwards. So let's learn about layout management in PyQt in the next lecture. In this particular lecture, let's learn about layout management in PyQt. So layout management in PyQt is nothing but it's simply a way of arranging widgets in a given window. So if you take a look at the code right here, which we have used for the previous lecture, this is the kind of window it produces. However, the way in which we have arranged the widgets onto the window is that we have simply used this particular move method to place widgets at a specific coordinate position. However, the problem with this approach is that these widgets are not even responsive. That means if you change the size of this particular window, as you can see, these widgets do not respond back and the size of the widgets do not change. Now, another disadvantage of using this kind of a method to place elements on the layout is that we need to know the exact position of where the widgets should be placed. So you might have come across several problems like aligning different widgets on the same exact row or the same exact column whenever we have used these X and Y coordinates. So in order to resolve this particular issue of actually knowing the exact positions and also of the widgets being non-responsive, PyQt actually provides us with an API or layout classes for better positioning of these particular widgets inside of the window or the container. Now, the advantage of using this API is that the widgets are automatically resized whenever the window is resized, and also we don't have to worry about the exact positioning of those widgets onto that window. PyQt actually gives us 3 different classes which we could use in order to manage the layout in a much more efficient way. And those classes are the QBox layout, the QGrid layout, and the QForm layout. So these are the 3 layout management classes provided by PyQt, which allows an efficient and a better arrangement of widgets onto our window. So let's first talk about the QBox layout. So the QBox layout allows us to place widgets on a given window in a horizontal or a vertical fashion. After the QBox layout, we have the QGrid layout, and the QGrid layout class allows us to place widget in a grid-like manner. So you could place elements in rows and columns fashion. And after this, we have the QForm layout, which is a class which allows us to create a 2-column form. So typically in a form, you have labels on the left and you have input fields on the right. And whenever you only have to create a form, instead of using the QBox layout or the QGrid layout, you could simply go ahead and use the QForm layout to create a form for accepting data from the user. So from the next lecture onwards, let's dive deeper into these kinds of layout types, and first of all we will start with the QBox layout class. So in the next lecture, let's go ahead and let's start learning about the QBox layout. In this lecture, let's learn about the QBox layout class in PyQt. So the QBox layout allows us to arrange widgets horizontally and vertically. Now we could go ahead and directly use the QBox layout class, but in order to make things more simpler, the QBox layout comes in two flavors, and those two flavors are QHbox layout and QVbox layout. So whenever you want to go ahead and place widgets onto your window in a horizontal fashion, in that particular case, we use the QHbox widget, and the QVbox widget should be used whenever we want to place those same elements but in a vertical fashion. So in this particular example, instead of using the QBox layout widget directly, let's use the QHbox and the QVbox layout class. So let's first discuss about the QHbox layout. So in order to create that layout, first of all, let's go ahead and let's get rid of the code which we have from the previous lecture. So make sure that you have deleted everything except for this particular initUI method. And once you have deleted everything, there's one major change which you need to make. So right now we are actually inheriting from the QMain window, but in this particular case, you want to inherit from the QWidget class. And I'll explain why exactly that is the case very soon. Alright, so once this particular QWidget class has been imported, now let's go ahead and let's create a couple of widgets here in the initUI method and then add it to that particular window or the widget and see the kind of result we would get. So let's first go ahead and let's create a couple of things. So in this case, let's say we actually want to create a layout in which we have a label, then an input field, and then a button. So let's create a label first. So I'll say label equals QLabel. And in this case, we won't be passing self here to this label, but instead we'll directly go ahead and pass in the text which we want to set for this label. So let's say this thing says name. So I'll directly pass a name here, and notice that we have not passed in self here. After creating this label, let's create a QLine edit widget. So that's going to be, let's say, name. So name is going to be QLine edit. And over here, either we are not going to pass a self, and we are going to learn why exactly that is the case very soon. But before that, let's create a button as well, which is going to be a QPush button. And let's simply add a text like add. And that's it. Now, once we have these three widgets, the reason for not adding self here is because we are not directly adding these particular widgets directly to the QWidget window, but instead we are going to add it to the layout. So in this case, now let's go ahead and make use of the QHbox layout. So in order to make use of that class, we first have to import that class from PyQt6.qtWidgets. So here I would say import the QHbox layout. Once that is imported, now we could go ahead and create a layout from that. So let's create a layout here. So I would say layout equals, that's going to be QHbox layout. So here, as you can see, we have created an object of this QHbox layout class, and this actually gives us a layout. Now, once this layout is created, we now have to take all of these widgets and then add those widgets to this given layout. So now the question is, how exactly are you going to go ahead and add that? So in order to add those widgets to the layout, you have to say layout dot and use the method which is add widget. And using the add widget, I simply have to pass in the widgets like label. After the label, I also want to pass in the name and the button widget. So here I would say add the name and then add the button. And now, as this is a QHbox layout, these widgets will now be added to this particular layout in a horizontal fashion. Alright, so now it seems like we are almost done, but now the problem is that we have created the layout, we have added the widgets on the layout, but then we now need to associate this particular layout itself to the main window, which is the QWidget window which we have. So in order to associate that, first of all, I have to get access to the window itself. So over here, I would now say self to access the window or the main QWidget, and to this main widget, now we will add this layout widget. So self dot, I would say set layout, and I want to set the layout to the layout which we have created. So here I would say layout. So what this line of code does is that it takes the main widget, which is the QWidget, and it takes the layout which we have here and it sets the layout of that widget to the layout which we have. And this layout now also automatically has the label, name and button added. Alright, so now let's run this code and see the kind of result we would get. So when I run this time, as you can see, we got the widgets added up over here. So we have added the widgets to the layout, and then that layout is added itself to this particular window which we have, which is the Q widget window. And one more interesting thing about these widgets now is that they are fully responsive. So if you kind of increase or decrease the size of your window, the size of the widgets is going to adjust automatically as well, and therefore we say that these widgets are now responsive. And if you have simply used the move method, in that particular case, you would have to know the exact coordinate points to place these particular widgets, and also those widgets wouldn't have been responsive either. So this is one major advantage of using the QBox layout class. Now we have learned about one flavor of the QBox layout class, and that is the QHbox layout. But similar to this, we also have a QVbox layout as well. So the QVbox layout is used to create layouts whenever we want to place elements in a vertical fashion rather than in a horizontal fashion. So now let's go ahead and let's take an example of that as well. So what happens if I simply go ahead and change this thing to QVbox layout? You also need to import QVbox layout from here as well. Alright. Right now, if I go ahead, close this, save this code and rerun this code one more time. Now, as you can see, the widgets which we had up over there are now arranged in a vertical fashion. So this is how you could go ahead and use any one of the flavors of the QBox layout, either the QHbox layout or the QVbox layout, and create layouts for your application. So in the next lecture, let's go ahead and let's learn how we could use a combination of the QHbox as well as the QVbox layout in order to create a nested layout. So let's learn how to do that in the next one. In this particular lecture, let's learn how we could create a nested layout using the combination of QHbox and QVbox layout. So in this particular example, we will be combining the QHbox and the QVbox layout together to form a nested layout where we use both the layout classes. So in order to take this example, let's get rid of all the code which we have from here. And instead of this, now we will be creating 4 buttons here just to display them inside a hybrid layout or a combined or nested layout. So let's create a couple of buttons here which are going to be push buttons. So I would say button 1 is going to be Q push button, and I simply would say this is a button 1. Similarly, let's create 3 more buttons here, and let's name these as button 2, 3 and 4, and let's replace the text as button 2, button 3 and button 4. Now let's assume you actually want to go ahead and add these buttons to the main widget which you have here, which is this Q widget. Now even before adding it to the main widget, you first have to go ahead and create a layout using the QHbox layout. So first of all, here we will be creating a horizontal box. So we will be creating 2 horizontal boxes here, and we will place button 1 and button 2 onto one horizontal box, then button 3 and button 4 on other horizontal box. So let's create our first horizontal box here by saying hbox1 is going to be QHbox layout. So here I would say QHbox layout. And you also need to make sure that you have imported that QHbox layout from here. So import the QHbox layout. And to this particular layout, once the layout is created, I'll add in the button 1 and button 2. So here I would say, take the hbox1. So hbox1 dot add widget, and we want to add the widget which is button 1. Similarly to this hbox1, let's also add button 2. So right now we have created one hbox in which we have added button 1 and button 2. Now similar to this, let's also create another hbox layout here, and I'll call this layout as hbox2. This is also going to be a hbox layout. So QHbox is going to be the class which we will be using. And in here, I would say hbox2 dot add widget. And here we will add a widget which are button 3 and button 4 to this particular second hbox. So button 3, and then let's copy this, and over here I would say button 4. Alright, so now once we have added these 4 buttons to 2 different HBox layouts. Now let's make a VBox layout itself, and on that particular VBox layout, we will add the HBox1 and HBox2. So first of all, I'll create a VBox layout by saying VBox equals, that's going to be Q VBox layout. So once this VBox layout is created, now I could take these two HBoxes which I have, and then I could add it to this VBox which I have. So over here, I would say, all right, take the VBox which we have just created. So I'll take the VBox, and then I want to add the HBox1 and HBox2 to this. Now I could say VBox.addWidget, but what this does is that it actually allows us to add the widgets, but instead this H1 and H2 are not widgets, but they are layouts. Therefore, to add a current layout to an existing layout, I have to say add a layout instead. So I'll add the HBox1 layout, and after that I'll also add the HBox2 layout as well to the VBox. After this, we finally need to go ahead and add this VBox itself as a layout to our main Q widget which we have. So over here, finally I would have to say self.setLayout, and I would set the layout to the VBox layout. So now what happens is our application creates the main widget, which is the Q widget, and this Q widget's layout is now going to be set to the VBox layout. And the VBox layout itself has two layouts set inside of it, which is the HBox1 and HBox2 layout. So we have nested one layout inside another. And also, if you take a look at the HBox1 and HBox2 individually, both of them have button 1 and button 2 and button 3 and button 4 respectively. So now let's go ahead and run this code and take a look at what exactly is happening here. So I'll run this code. Now we have 4 buttons here. So this particular widget right here is our Q main widget, which is our main window. And to that particular widget, we have our main VBox layout setup. So as we know that VBox layout actually adds elements in a vertical manner. So therefore, as the VBox widget or the VBox layout contains HBox1 and HBox2, this right here is HBox1, which contains button 1 and button 2. And this right here is the HBox2, which contains button 3 and button 4. And as these two things are HBoxes, the elements are laid in a horizontal fashion. However, as the outermost layout is a VBox, these elements are laid out in a vertical fashion. So this is how you could go ahead and make use of the Q HBox layout and the Q VBox layout in combination with each other to create a layout which looks something like this. So in the next lecture, let's go ahead and let's learn the next type of layout which we could use to design our applications, and that is the QGrid layout class. So let's learn about QGrid layout in the next one. In this lecture, let's go ahead and let's talk about the QGrid layout widget. So the QGrid layout widget, as the name signifies, actually allows you to place elements in a grid-like format. That means you could place elements in a row and column manner, which means whenever you create certain widgets, each row and each column which you have on your layout has a specific number. And in order to place widgets in these rows and columns, we simply have to specify those row and column numbers. So let's go ahead and let's try to take an example here. So let's get rid of all the code which we have from the previous lecture. So I'll go ahead and delete all the code in the init UI method. And in here, let's create a couple of sample widgets. So let's create 3 labels and 3 buttons. So I'll create a label 1. This is going to be a Q label. And let's directly pass in the name of the label as label 1. Let's copy paste this, change the name of this thing to label 2, label 3. And after this, let's also create a couple of buttons. So I would say button 1 equals, this is going to be a Q push button. And let's directly add the names for these buttons as well. So this is going to be button 1. Let's copy the name. Let's copy this, button 2. And then let's finally have button number 3 here. So this is going to be button 3. Alright, so once we have the labels and the buttons, the next thing which we need to do is we need to go ahead and create a grid layout. So in order to create a grid layout, I simply have to say layout equals, that's going to be grid layout. So in order to create a grid layout, you need to import the QGridLayout class. So we have to import it from the PyQt6.QtWidgets module. So here I will import the QGridLayout, give a comma, and now we should be able to create a object of that particular class. So this is going to be QGridLayout, and we don't have to pass anything over here. But now let's go ahead and let's set the layout of our main Q widget to this particular layout. So here I would say self.setLayout and set the layout to the grid layout which we have created. So I would say layout. So once the layout has been set, now we could go ahead and add the widgets which we have up over here to the layout. Now the method which we will be using over here is going to be the same add widget method. So first of all, I'll take the layout which I have. So I would say take the layout, which is the QGridLayout dot add, and here we have a couple of methods like add child layout or add child widget, but we will be using the add widget method. And over here you could pass in label 1, and then you also have the option to specify the row and column number, as this is a grid layout. So let's say I want to place label number 1 at 0th row and 0th position. And after that, let's go ahead and add the second label at a different position. So I'll copy this, paste this code up over here. Let's add label 2. And this time, instead of placing it at 0th row and 0th column, let's say we want to place it at 0th row and 1st column. So for now, even before we add another widgets here, let's see how this kind of looks like. So I'll go ahead and run this code. And right now, if you could take a look at this, this is how our label looks like. So here we have placed label 1 at 0th row and 0th column. Then here, as we have set 0th row, this label is in the same row as label 1, as both of them are present in the 0th row. However, the second label is present in column number 1. So this right here is column 1, this right here is column 2, and this is 0th row. Alright, so let's add the rest of the widgets now. So I would say layout.addWidget. Let's add label number 3. So let's say I want to add label number 3 over here right next to label number 2. That means the row number should be the same, which is 0, and then the column number should be 2. If I do that, I have to go back, close this, rerun this code. And if you take a look at the result here, this is what the result looks like. So we have label 1, label 2, and label 3. Now let's say we want to take these buttons and then place them beneath these labels which we have. That means now we need to shift these buttons to a new row. Therefore, in order to do that, I would say layout.addWidget, add the button 1, and this time we increment the row number. So this time the row number becomes 1 and the column number is 0 for button 1. If I save this, I have to close this one more time, run this code, and you'll be able to see that the button 1 will be added right beneath label 1. So now let's go ahead and let's add the rest of the buttons. So we want to have the buttons on the same row but on different columns. So therefore the row number would be 1. Let's simply change the columns to 1 and 2. And this should be button 2 and button 3. So if I save this, run this, as you can see, we have button 1, button 2, and button 3 placed here. And I guess we have misspelled this. This should be button 2. And if we do that, now everything should work absolutely fine. And we should have 3 buttons beneath 3 labels which we have. So as you can see, our layout looks pretty much ready. So this is how you could go ahead and make use of the grid layout or QGrid layout to basically lay out your widgets in a row and column like fashion. So in this case, you don't have to specify the coordinate points, but you could directly specify the row number and column number, and it's automatically going to create that layout for you. One more thing about this is that this particular QGrid layout is responsive and flexible. That means if you were to go ahead and increase the size of your window, the size of the widgets is going to adjust accordingly. So that's it for this lecture, and I hope this kind of gives you an idea about how this QGrid layout works. And this QGrid layout gives us a lot of flexibility in designing the complex user interfaces. So from the next lecture onwards, Let's go ahead and let's start working on a complex project and apply all the concepts which we have learned till this point. So from the next lecture onwards, we will be creating calculator application using PyQt. So let's learn how to do that in the next one.